Welcome back, everybody. This panel is going to focus on sustainability and some of the cool things we're doing at the Cove. But just to start and put us in perspective, cities today are under increased environmental threat. Much of our valuable infrastructure, waterfront, and neighborhoods lay exposed to future impacts of climate change. So why don't we start with the first slide. The question is, how do we build sustainable communities that will thrive well into the future? Do you have a slide? Yeah. While we work through our technical issues. Do we have our slides available, or should we just keep going? Keep going.
Keep
okay.
going.
So how do we develop sustainable communities that will thrive well into the future? Our 3.1 million square foot Cove development will be among the first large-scale regenerative carbon-neutral innovation communities in the Northeast and maybe in perhaps the United States. Designed to showcase resiliency, high-performance architecture, and wellness, the Cove will set new benchmarks in major urban developments. We're transforming a toxic, flood-prone site into a healthy urban live, work, play environment. We're creating spaces with abundant daylight that engage the natural environment and promote good health. We are also leveraging integrated high-performance design to achieve a carbon neutral development. Our path to carbon neutrality has hovered. Actually, I need a diagram to speak to. Can we not get the images? So I guess I'll keep going. So, path to carbon neutrality in the built environment involves integrated design. We first start off with developing very efficient systems, passive systems that have to do with proper building orientation, high performance facades, a lot of insulation in our walls. We engage our engineers and develop very low energy mechanical systems to heat and cool our buildings. But buildings fundamentally consume energy, and we've done a great deal to create efficient buildings that will perform well into the future, but it's not going to solve the problem of climate change and the amount of carbon reductions that are required to reduce the more severe impacts of climate change. So today's panel, we're going to focus on the ground plane and some of the cool stuff that we're leveraging what lies beneath to create a resilient development that will reduce its carbon footprint and, again, thrive sustainably well into the future. My name is Chris Stoddard. I'm with Ennead Architects. And joining me today on my panel, I have Jim McGuire, Water Innovation Lead at Tetra Tech, and he's our renewable energy specialist. Our site remediation experts are Douglas Newman, Director of Environmental Services at Dresner Robbins, and Chris Collins. He's our civil engineer and project manager for the project, and he's been helping us navigate the complicated environmental approvals required for our site. To kick things off, let's just talk about energy. Jim, carbon neutral and net zero development is the new gold standard in commercial development. To start, can you just give us a simple definition of carbon neutral versus net zero and the nuances between the two?
Simple. You said simple, right?
Yeah.
Okay.
As simple as we can.
Yeah, sure. Well, I think what's exciting, first of all, is that you're seeing both the private and the public starting to develop commitments to changing towards this new energy economy and the importance that future economic growth is becoming inextricably linked with taking care of the planet. So I think that's the one thing that both of these definitions have in common, is that they both acknowledge the criticality of making that link between the environment and future growth of the economy, that the two are inextricably linked. So from there, both carbon neutral and net zero begin by being very conscious and aware of all development and operational activities with regard to their accounting of greenhouse gas emissions, specifically carbon dioxide. So they're common in both those facets. They depart a little bit in that carbon neutral is it's probably about a 15-year-old term. It starts to make or begin the conversations of a commitment to looking at what is business as usual, looking at what can be done to reduce the carbon intensity of an activity or a corporation or an operation, and then where it cannot be leveraged on-site or by changing in practice, there are offset programs available somewhere that allow for sequestration of carbon dioxide or carbon negative opportunities. And that's kind of a simple definition of carbon neutral. Net zero, at least in my mind, because I'm an engineer and I do like graphics as well, I always have to have visuals. Net zero is really kind of taking that responsibility and bringing it onto a site, like really kind of thinking within the fence and saying what device or what approach could one take to truly be net zero? In other words, not need an offset because you've done the work economically, technically, administratively to come up with a solution that is truly net zero. There's no carbon generated or no reliance on fossil energy to commit an operation or conduct an activity. So hopefully that's simple.
That's great. If we could move a slide or two forward to keep going. One more. So this is what I was talking about earlier, a path to carbon neutrality. The building industry has done a really good job on the left side of the graph using passive strategies, efficient systems, and controls. But again, it's not enough. Even with our Cove project, we're going to be capturing energy to heat and cool the buildings, but there's still a lot of power still required to run fans, pumps, light the building, et cetera. So we'll be looking into additional on-site renewables like integrated solar and maybe some offsets. The state of New Jersey, most of the power is provided through either nuclear or natural gas means. So there's still a carbon footprint inherent in the grid of the state of New Jersey. So we're working very hard to get to true carbon neutral development with the Cove. So the year 2030 is the current federal government benchmark for achieving a 50% reduction in carbon emissions from 2005 levels. How does the Cove help meet or exceed this benchmark?
Yeah, excellent. One of the things I find fascinating and aspiring about this project and its commitment to these goals is that the UN has sustainable development goals. So here we have a global organization thinking about what are some of the SDGs, they call them, that are critical towards continued economic growth, health of the planet, progression of societies throughout the world. Underneath that, the UN has an environmental program that really kind of goes down one level more granular and says, these are the things that we need to be doing globally to really address climate change on a global scale that actually has real impact. And when you look at those programs, and this program specifically talks about the importance of campus energy and district energy, that we have to rethink the way we heat and cool our buildings. The Cove provides an excellent opportunity to line up with these goals and strategies that are at a global scale. So that's one of the things that I find very exciting about the Cove. It is, in fact, a great way of lining up with global aspirations. And of course, there's the ability to do what we see here on this graph. I think the multiplier effect for the Cove is that, and I've seen this in other regions of North America, is that it will, through demonstration, inspire other developments to frame themselves around redevelopment, around district and campus energy, and there'll be a multiplier effect. Plus, you have to also appreciate all the learning opportunities very local here, and you could just imagine kids in grade school coming through here and seeing a district campus energy system and being excited about their civil infrastructure and what they may do as future civil engineers, environmental engineers to help this transition towards a more sustainable built environment.
So Clay earlier in the day mentioned the waste energy aquathermy technology that we're going to be implementing at the Cove. Could you please drill down into that, talk about the science behind it, the studies we went through to understand its viability, and how it's going to work?
Yeah, sure. Well, it just turns out wastewater is warm. So we all pay a natural gas bill every month for our apartment or our residence. We maintain the heat within a water heater. Then we spend, I don't know how long a droplet takes from your shower head to the time it goes down the drain, but it's not long. So when you think about all that embodied energy within wastewater, it's amazing. And wastewater as an infrastructure has gone through this change. In the 20th century, it was about cleaning up the environment, water pollution. Now it's about becoming a platform for resource recovery. So thermal energy from wastewater is a fantastic resource recovery opportunity. And you can appreciate from this view that the wastewater used to be called sewage. Now it's called used water or wastewater. It flows under the site here. And it's several 100,000 people's worth of hot showers, dishwashing, laundry, a lot of embedded energy within that flow. So technically, there's not a lot of technical innovation. It's very much heat exchangers, a lot of the campus energy type technologies that have been around for a while. It's just an innovative concept of grabbing what local sources you have available on a site for heating and cooling that's completely different than the way we thought about things 10 or 20 or 30 years ago.
Where else are you using this technology?
So there are some certain hotspots globally. Northern Europe, a lot of the countries in Northern Europe have mandates with regard to disconnecting from fossil-based thermal energy sources. So in those regions, in like Finland and Sweden and Norway, these energy utilities are literally going to their water plants or their data centers and saying, hey, we need to unhook our natural gas and we need to hook up to a low-grade but viable thermal energy source. And so obviously Northern Europe is way out, and by example, we get to benefit from what they've completed in Northern Europe. British Columbia and a lot of areas, Montreal, a lot of the Canadian cities are really moving along with this campus energy concept, including rivers, canals, wastewater systems, drinking water distribution systems, anything locally available as a potential low-grade thermal source for heat pump technology.
Great.
And of course, Denver, Colorado has an excellent installation as well.
So the Cove is a mixed-use residential live, work, play environment. What are the synergies between buildings in terms of how they use energy, when they use energy, and the amount of energy they use throughout the day?
Sure. I've been working closely with my partners at Cosentini on the energy models and understanding just the dynamics of a building. You can imagine we all have this pattern where we all generally sleep at the same time, get up at the same time. our lives are very similar in terms of a profile. So the buildings respond to that profile, and so the energy demands in a building move around quite a bit. But this concept, it's sometimes called fifth generation or eco loop, is in essence, you link up onto a closed loop, and buildings pull or push heat into this loop as they require. So it sets up a lot of opportunities for, while one building is seeking to cool, there's another building seeking to generate hot water. So there's a lot of, kind of the sharing economy a little bit with thermal energy, and that's what a campus energy system allows an architect and the engineers to really think about where there's synergies in terms of balancing energy and cooling needs.
So when I think of district heating and cooling plants, at NEAD we do a lot of higher ed work, and you often see this big kind of ugly central plant on the edge of campus. What is this going to look like? And is it scalable? How can it come online and adapt to the development as projects get built over an extended period of time?
Yeah, that's a good question. So very interestingly, the systems that I've worked on and have visited, a lot of thought goes into what this central utility plant would look like. And since it's not your traditional cogeneration plant, it's not going to have the cooling towers and all those things, because there's not a lot of waste heat. It's very efficient. So they tend to be, I think for the Cove, it would be about a 10 to 12,000 square foot campus utility plant. And good city planning and architects allow for this building to really kind of blend into the surroundings. A great example is Neighborhood Energy Utility in Vancouver. And this campus utility plant is really kind of gently tucked underneath an overpass. You'd never notice it unless you went out to look for it. But it's recovering heat from wastewater passing by and provides heating for several million square feet of commercial and mixed use areas. So very different than the traditional steam plant type look. Yeah.
And what are some of the challenges? Regulatory approvals, legal issues?
Yeah, that's a good question.
We're going into kind of new territory in terms of implementing this system in Jersey City.
Yeah, so I'm an optimist, so I always see the possibility in things, and so technically, I don't think there are any challenges. I think the challenges, really maybe the challenges sit in one space, and that is through the 20th century, we built a lot of infrastructure. I mean, you could look around you and appreciate that. All the wastewater conveyance infrastructure, the fact that the Hudson River is now clean, that was the wicked problem of the 20th century, is that river was dirty, now it's clean. That's allowed for redevelopment to reconnect with the river since it's a clean environment. While all this infrastructure went into place, we developed silos of excellence within utilities, within city governance, within policy, and innovation requires collaboration. It requires new ways of doing things, and I think that's going to be the type of challenge is reimagining what we're all after, and then coming back and looking at silos of governance and policy and kind of saying that's served us very well in the past, but this is a new time, this is a new period in our history, and we may have to rethink the way we establish government and policy and maybe change some things up a little bit. So that's kind of where the change gradient would occur that would present challenges.
Awesome. Thanks so much. Let's move on to the site. The Cove, it's a tough site. It's flood prone. It was a very toxic site before you became involved. Doug, you have deep experience dealing with sites such as these. Explain how you started to approach how do you remediate the site and make it a site that is a benefit for development?
That's a great question. I don't think we have enough time on this panel to get to all those answers, but I've been involved with this project for over 15 years, and so I've got certainly a personal connection to it, and it's really exciting to finally see some redevelopment activities actually start. The investigations that we've been conducting have been done on behalf of the agency as well as the private landowners, including Argent. And those investigations included, but were not limited to, advancement of soil borings, installation of monitoring wells, collection of soil and groundwater samples, aquifer studies, of course, laboratory analysis. The purpose of those investigations was to identify concerns, and once they're identified, to extrapolate and try to horizontally delineate the extent of those problems. From a high-level standpoint, the principal findings of those investigations identified the presence of historic fill, which is something that we see throughout the Jersey City waterfront, very common in the area. This area was inundated with water originally, and the material that they used to fill the area was contaminated upon its placement. So that's very common in the area. But above and beyond that, our focus was to deal with all of the potential discharges from all of the industry. We saw some of these slides earlier. You see the area littered with railroads, shipping yards, and all sorts of industrial activities, of which have had a lot of discharges over those 100 years of operations there. The contamination that we've identified on these sites, above and beyond the historic fill, includes PCBs. PCBs is probably the most widespread contaminant that we're seeing across these sites. It's also the primary remedial driver when it comes to excavation and off-site disposal. Chromium, we're also seeing chlorinated solvents, petroleum hydrocarbons, and things like that. So I think the biggest challenge that we faced on sites like this that have such an extensive history is that we're not dealing with a single discharge of a single contaminant. We've got years and years of discharges of a variety of different contaminants. And because of the state's requirements to get in there and investigate and then delineate, you're dealing with many, many different compounds, and you're trying to delineate them to parts per million and parts per billion, which is really challenging. So I think the other challenge that we've dealt with on this site is just the vast amount of data that's been collected over the last decade. It's just we're talking thousands of samples, and it's to be in a position to review and interpret all that data and draw conclusions and make recommendations was really challenging. We really relied extensively on a database, the use of GIS and other mapping software to help us make those decisions. But in large part, the majority of the investigation has been completed on the first phase of the development, phase one. I think there's some shots here you could see of some of the excavation that took place. I think one of the biggest challenges that we dealt with was a shallow groundwater table. Groundwater at these sites is only a few feet below grade, and we had excavations that were extending well beyond that, in some cases 20 feet. So it was a huge engineering challenge to figure out how to deal with that. Obviously, extensive dewatering operations had to be considered. We installed hydraulic sheeting surrounding all these excavations. Monitoring wells and pumping wells went into these excavations. And of course, as you could think, huge volumes of groundwater is going to be generated during remediation. It was not an option, not feasible to containerize all those fluids. So we designed and permitted a mobile groundwater treatment system, which was brought onto the site. All of the water that was generated during dewatering was treated through that system and then discharged to the nearby surface water body through a PBR permit. Other challenges that we faced on the remediation project, I think just some of the variables that we had to deal with, just space. As big as this project is, there was a logistical nightmare at times trying to avoid painting yourself into a corner. Took a lot of planning. We had 30,000 tons of material that came out that was stockpiled. That is a lot of stockpiles. And all of those stockpiles had to be segregated for the various waste streams, so they had to be managed, really excellent record keeping. Finding homes for some of this material was challenging because of the commingled nature of the contaminants. There are just not a lot of facilities that are permitted to receive this kind of waste. And then even the weather, just when you think we were in the home stretch, I think it was probably in January or February, we had 2 feet of snow dumped on us, and that snow didn't melt. So now we had mountains of snow to deal with no place to put them. So a lot of challenges in the phase one remediation, but ultimately at the end of the day, we successfully completed the work. I think we had a good team, and I think the selected remediation contractor, NTAC, did a really nice job.
Awesome, awesome. And there's a phase two. correct?
There's going to be multiple phases. I think at this point, at least 3. And hopefully the next phase of the remediation, which will probably include Mill Creek, as we call it today, will probably be starting in the next year and a half.
Great, great. So, clearly a challenge and lots of bad stuff that you have to get rid of and dispose of in the proper way. Why redevelop a brown site? I'll give that question over to you, Chris.
Sure. You think about what makes a brownfield, and it's the presence of former industry on the site. Why did that industry want to be where it existed? Primarily 3 reasons. Proximity to commercial hubs, such as New York, proximity to a workforce, as well as proximity to transportation. So when this area was developed for industry, all those ingredients were present. As our economy has shifted from manufacturing to services and research and those kinds of things, those are the same ingredients that make something like a life science hub or an attractive place to locate here. So you're not going to get that on a greenfield site because those things aren't present. It wasn't developed for that. The other thing that makes the Cove unique and that its brownfield nature particularly unique is that very often we're working on sites where there's a lot of other existing development. The Cove is basically a blank slate. And it's really an exciting design opportunity from an engineering and architecture standpoint to be able to essentially redevelop the entire site and create something brand new.
Great. So the site is cleaned and capped. How do you restore the ecology of the site? And what are the opportunities for doing that?
Sure. So this entire area, including the land that we are sitting on right now, back 200 years ago used to be oyster beds, tidal flats, salt marsh. And there's a little piece of that still remains on the Cove site that's been extensively contaminated through those previous industrial uses. And that's part of the later phases of remediation. But we have an opportunity to restore that into what it was before and create a focal point for the rest of the development, a place where people can gather and enjoy nature. And it's also going to dovetail nicely with the ecological restoration that's going to happen at Liberty State Park, not too far from here. That's going to be a joint effort between the State Department of Environmental Protection and the Army Corps of Engineers. That'll be happening fairly soon, and it's basically the same concept as what we're proposing here at the Cove.
So working with you, there's all kinds of regulatory issues that we've confronted. How are those regulatory hurdles changing as we adapt to the issues of climate change, and how are we addressing those issues at the Cove?
Yeah, so the governor's office in the past few years has issued a few executive orders that are aimed at getting the state agencies, such as the Department of Environmental Protection, to start considering the effects of climate change in their rulemaking and policymaking and other decision-making processes. And we don't know necessarily the outcome of that right now, but what we can anticipate is that the regulations on things like tidal flooding and mitigating and adapting for tidal flooding are only going to get more strict. So at the Cove, our resiliency berm, as Clay mentioned earlier, is going above and beyond the elevations that are required by current regulations to take into account the effects of future sea level rise and make it a sustainable and resilient development for the next few decades.
Great. One other issue that we've been working hard to address is the problem of combined stormwater sewer. Jersey City has a combined stormwater sewer that flows into our waterways, similar to New York City, during heavy storm events. What's Jersey City doing to address that issue? And again, how does our project dovetail into that mandate?
Sure. I think there was a slide on that that would be helpful to show here. But Jersey City, like other combined sewer municipalities across the country, is under a mandate from the EPA to reduce the amount of sewage that flows into local waterways when it rains heavily. As Jim mentioned, the Hudson River's clean, but there's still some work to be done to reduce the amount of sewage that flows into it. So on this project, what we're proposing in a partnership with the Jersey City Municipal Utilities Authority is a combined sewage holding tank that would intercept some of that overflow before it gets into the river, and then it would be stored temporarily to be treated later. And this is something that's been done across the country, places like Boston, Washington, D.C., Chicago, and as Jersey City is embarking on its own journey to mitigate their CSO issues, we're going to be right at the forefront in helping the MUA implement their mitigation plans.
Awesome. In addition, we have a wonderful, clean site that will help address some of the issues of climate change. We've got renewable energy on site. We're going to be developing a series of beautiful buildings. The issue of buildings and the built environment we're going to get into during the wellness panel. Peter Schubert, partner at ENIAD, and my colleague will be speaking further to that. But do we have any questions in the audience for this panel?
I might have missed this, but what will be the total cost of the environmental remediation of the site? And what percentage of the total project would that be? And how would that compare to other typical site costs?
I can answer at least one of your questions. It was discussed earlier on one of the other panels. The cost for the remediation of phase one that was finished in March of this year was $11 million. I don't think we really fully understand the future costs for remediation yet because those properties are still being investigated.
And does the state of New Jersey offer financial benefits for remediating brownfield sites?
There are a variety of programs that are available, but it depends on who the applicant is.
Mm-hmm.
So for instance, some of these sites that are owned by the redevelopment agency can get brownfield funding because it's a public agency. Sites that are owned by private landowners cannot. So there's certainly a lot more funding available to the public entities than there is to private landowners.
A project of this size in many communities would have a lot of community input, and opposition potentially. Since I assume there wasn't much community input, or is there a community around it? Can you talk a little bit about how the community supported it or any kind of involvement?
Maybe Clay, if you want to speak to that a little bit.
So yeah, I mean, we don't have actually any neighbors, immediate adjacent neighbors, and there's no residential around us. So we did go through, when we did the rezoning in 2017, a pretty comprehensive community engagement process. We went over here to the Paulus Hook Neighborhood Association, Van Voorst. We talked to the Morris Canal Group as well. Several meetings with Van Voorst to go over the project and everything. We got very minimal feedback. Most people were more concerned about the impacts from the traffic from the Jersey Avenue Bridge than they were with anything that we were doing. But we did, and we have had quite a few conversations with Friends of Liberty State Park and Rob Rodriguez and the park staff about making sure that whatever we're doing is, incorporating some of their future improvements as well. But by and large, I think the feedback was pretty positive.
Are there any more questions?
How does this project become the model for discussing sustainability in projects going forward in the New York City and New Jersey area, specifically around that sustainability and growth should be discussed hand in hand?
Can you repeat the last part?
How sustainability and growth should be discussed hand in hand, that they're not competing ideas.
Mm-hmm. Well, engaging the life science community and the facilities that are needed to support life science companies is very unique. They're buildings that require special systems, systems that are more robust than your typical office building. There's a lot of discussions about, in the New York region, vacancy rates are very high, but you can't just insert a lab environment into an office environment. It's very different. So there's a demand for new life science buildings. With that, we're trying to create an integrated community that you can live, you can walk to work, you can engage a public park, and live a full life within a 15-minute walk of your live and work environment. It's also not dependent on the automobile. It's conveniently located within a robust network of transportation networks. So just strategically, we're addressing the need for space for certain kind of commercial use and academic use for that matter, but also creating a integrated mixed-use environment. Addressing that further, we're remediating a Brownfield site that was a fallow site, polluting our harbor, and we're also creating a renewable energy system to heat and cool the buildings with nominal carbon footprint. So you take that all inclusively, there's very few developments out there that are going to the extremes that the Cove is taking in its execution. Did that answer your question? Any further comments on that?
I would just only add that, with Jersey City having a climate energy plan, and others, New York City has local law 97, that type of leadership kind of puts it out there and kind of lays the platform and lays the foundation and lays the motivation for a development like the Cove to respond to and to be a part of. So I think that always seems to be the very first step that's important, is that strategic directive in some form that kind of gets redevelopment linking thoughtfully and strategically with sustainability, and in a way that's consistent with rolling up through city government and all the way up to the United Nations. So.
And it's hitting the 3 points of sustainability: financial viability, environmental, minimizing environmental impacts, and creating a social network for people to live a healthy life. Any other questions?
I'm not sure if this was mentioned or I missed it, but I'm not sure if it's a panel question or a Clay question, but I'm curious as to the development and the progression of the project goal as far as the net zero aspect. Like, did the discovery of that main sewer line change kind of, or was that noticed early on and it became kind of a steering point for the project? I'm not sure if I'm wording that correctly.
Well, yeah, that's a great question. It's something that came not from the onset. It was discovered, during the master plan process. And there's a lot of aspirational carbon neutral developments that have been designed out there, whether it's here in the US, in Asia, or elsewhere. And they tend to fall flat because they don't meet their financial expectations. It's very expensive to implement technology, or the technology is not there. This is really a perfect storm where we have this advantageous relationship to the sewer main that goes from Jersey City to the north to the treatment center to the south. And it's a great opportunity to leverage that. In terms of the site resiliency and other infrastructure issues, they're inherent with the site and the site conditions, and we've been addressing those for some time. But it's really a perfect alignment of opportunity to do something great here. It's very unusual, and look forward to seeing it realized. All right, I think we're done. Thank you very much. Everybody go get some food.